So for part A, with our grass clippings that are being placed in this bin, first thing we want to look for is the average rate of change of A of t on the interval from 0 to 30. So just remembering that average rate of change is not average value. So this is not the mean value theorem for integrals. Average rate of change is just a slope. So we are just looking for the slope between 0 and 30 of A of t. So A of 30 minus A of 0 over 30 minus 0. And obviously, you'll use your calculator to figure out what 0.931 to the 30th is and multiply it by 6.687. According to the answer key here, the scoring guidelines, it comes out to be negative 0.197. And they want us to indicate units of measure. And so this is A of t is pounds, t is days. So we're doing pounds divided by days, or pounds per day. And that incredibly difficult part was worth 1 point. Everybody good there, part A? Cool. All right, part B. We want to find the value of A prime of 15. So, I mean, that should be pretty easy. You just use your calculator. No reason to actually take the derivative by hand. You could if you wanted to, but no reason to. Just type in the function into the derivative thing on your calculator. Value it at 15, and you get negative 0.164. And it says using correct units, interpret the meaning of this value. And so this is the derivative of A, which means it's the rate of change of A. So basically, we're saying that the amount of clippings that are placed in the bin is decreasing. So we'd say amount. Well, actually not there. The amount remaining. So the amount in the bin is decreasing at 0.164, and it's same units as part A, pounds per day. And we might want to include at t equals 15. Good or no? 1 point for the value, 1 point for your explanation. Everybody good with that? Or? All right, part C wants us to find the time for which the amount of clippings is equal to the average amount of clippings. So first off, we need to figure out what is the average number of clippings. So the average number of clippings ought to be, this time it's the mean value theorem for integrals. So that ought to be 1 over 30 minus 0 times the integral from 0 to 30 of our A of t dt function. And we want to know when is that equal to the actual amount in the bin. So that would be equal to function A of t. And we're just solving this for t. Yeah, I mean, the integral you'll get a value for, you multiply it by 1/30th, and then you'll just set that equal to the function. And it comes out to be t is 12.415. And that was worth 2 points. Also 1 for setting this up properly with the mean value theorem, and 1 for getting the answer. Any questions there on part C? Everybody okay with that? All right. Part D, for t greater than 30, they're saying that the linear approximation to A at t equals 30 is a better model for the amount of grass clippings. use that L of t to predict the time when there will be a half a pound of grass clippings remaining in the bin. And so the linear approximation or the linearization for A, we'll call it L of t, that should always be equal to the value that we're approximating at, which is 30, plus the derivative at that 30 value, times whatever t value we're looking for, minus the t value that we're centered at. So amount at that, or amount, the function evaluated at the center of approximation, plus the derivative at the center of approximation, times our x value minus the center of approximation. A of 30, did we already find A of 30 and A prime of 30 up here? I don't think we did. No, and yeah, we didn't do any of those problems. So you'll find what A of 30 is, and you'll find what A prime of 30 is. And you'll set this whole thing equal to 1/2, 0.5, and then you'll just solve it. So scoring guide says A of 30 comes out to be 0.782928, and A prime of 30 is negative 0.055976. And so you just graph that and you graph this and see where they intersect. And it came out to be 35.054. And this one was worth 4 points. So you get 2 points if you just had this expression here for L of t. That's 2. 1 if you set it equal to 1/2, and 1 if you finally solved it and got the right answer. Any questions or issues with that one? Everyone's good. All right, spectacular. Okay. Next one I asked you, this one was not a calculator problem. So this one is about making coffee. That sounds awful. We got hot water dripping through the coffee maker, et cetera, et cetera. C is the amount of coffee in the cup, measured in ounces, T is minutes. And we got a nice little chart. Doesn't specify that our function is always increasing, even though it looks like in the chart the function is always increasing. It doesn't necessarily mean that it is always increasing. So just keep that in mind, because sometimes they will make it look like it's always increasing or always decreasing, and then ask about like under approximations or over approximations. And just because you have a chart that looks like it's increasing, unless they state that it is, it's not always constantly increasing. Not that that matters in this particular problem, but just an important point to note. So part A here, we're going to use the data in the table to approximate C prime of 3.5. C prime of 3.5 can only be approximated by taking an average rate of change of some numbers surrounding 3.5. Seems like 3 and 4 would be the best. So C prime of 3.5 ought to be our value at C of 4, so that's 12.8, minus our value at C of 3, which is 11.2, over our 4 minus 3. And 12.8 minus 11.2 is 1.6 over 1, and this is ounces per minute. And they gave you 2 points, 1 for 1.6. I don't know, I put 2 there as I said 1, and 1 for the correct units of ounces per minute. Any questions there on part A?
Mr. Bachelor.
Yeah.
So you wouldn't find like the actual like point of 3.5, right? Because like that's what I kind of did, and then I got the same answer.
What do you mean the actual point?
So like I used 3 and 4 and then just find the middle value.
I mean, that's effectively what we did here by just subtracting those and dividing by 1. But I mean, that's not the actual value of 3.5 for C.
Okay.
I mean, that's just, I guess I'm still not quite understanding what you mean. What are you, I'm not sure what you did.
So like I took 12.8 and I subtracted about 11.2.
Yeah.
And I just divided that by 2 to get like kind of like how much do I need to increase just to get a middle value. So then I got 12 for like 3.5.
And then you said what? And then what did you say?
So like I got the middle value of 12.
Yeah.
So then I took that and I just subtracted it by 3. I mean, like the 0.3 comma 11.
I got you. So you found this slope between 3 and 3.5.
Yeah.
I mean, that will effectively get you the same value. It's just a lot of extra work. So, I mean, not a lot. I mean, it'll probably only take you an extra 30 seconds, but I'd suggest just using the values that are already in the table. You don't need to find the value at that point. Just use the ones that most closely surround the point. If they ask you to approximate a derivative of something from a chart, just always then what they're expecting you to do is to just take, if they asked in this case for 5.5, you just take 5 and 6 and find the average between those. Or if they asked, for 0 or for like 1.5, you do 1 and 2. So your way will come out to be the same thing every time, but takes an extra step. So all right. Are you good, Darius? Or
yes, thank you.
Okay. All right, part B. We want to know if there's a time between 2 and 4 where C prime of t equals 2. So this sounds like the mean value theorem. If we're asking from values of C, if there's ever a time when C prime equals a specific value. So what we want to do is we want to look at the average rate of change between 2 and 4 and see if it is equal to 2. And if it is, then that tells us by the mean value theorem that since this is a continuous differentiable function, there must be a place on that interval where the average rate of change is equal to the instantaneous rate of change. So we'll do C of 4 minus C of 2 over 4 minus 2. I should have looked at what those values were, and I didn't. 12.8 minus 8.8 over 2 looks like that's equal to 2. And so you'll say C is continuous and differentiable. And we'll say you don't need to write out that the average rate of change on 2 to 4 is 2, right, which is what we just found above. So by the mean value theorem, C prime of t equals 2 on the interval 2 to 4. And that'd be good enough. It didn't ask us to find, it just said, is there a time? It doesn't ask us to find out what time it equals at the sun. And that would be worth 2 points. 1 for setting up this slope, and 1 for your conclusion using the mean value theorem. You had to use and specifically state mean value theorem. Any questions there on B? All right. Midpoint sum for C using 3 subintervals of equal length. So we'll use 0 to 2, 2 to 4, and 4 to 6. And we're going to approximate the value of 1/6 of the integral from 0 to 6 of c of t, and then explain what that means. So first off, we'll do our midpoint Riemann sum. If we're doing 0 to 2, 2 to 4, and 4 to 6, our midpoints will be 1, 3, and 5, obviously. Each of those intervals is a length of 2 units. Oh, sorry, I just saw your question, Nick. I'll go back to that. Yeah, I didn't use brackets there at the end because, well, I guess specifically they said on the closed interval from 2 to 4, the mean value theorem states that if the function is continuous and differentiable, then the average rate of change equals the instantaneous rate of change on the open interval. They said on the closed interval, so we could, I mean, if it happens on the open interval, it certainly happens on the closed interval also. It's just including those extra endpoints. So I guess I should have said, I probably should have said closed brackets there, 2 to 4. Although, if something occurs on a set of numbers, it also is guaranteed to occur on the set of numbers that is larger than it. So, that answers your question. I don't think they, yeah, I should have said on closed 2 to 4 just because that's what they said. But I don't think they take the points off. I think that they're competent enough in their grading to recognize that if it happens on the open interval 2 to 4, it must have happened on the closed interval from 2 to 4 also, I hope. But yeah, better to put what they say. All right, so we're doing our midpoint Riemann sum here for C. And let's see, I believe we had lengths of 2. The first one is 5.3, I think, at 1, and I don't remember the rest, 11.2 and 3.8. So that should be our midpoint Riemann sum, just for the integral from 0 to 6. And then we're also going to need to multiply that all by 1/6 at the end to find the value of 1/6 of that. Let's see here. So what do we get here? 25, 30.3. If we add those 3 things together, and then we got to divide that by 3, so it looks like that's 10.1. So this is 10.1, and I believe it's ounces for our units, right? And so what does this 10.1 ounces mean? Well, since it's 1/6, or 1 over b minus a times the integral, it tells us that's the average amount of whatever we had. So we were talking about coffee in a cup, so this is the average amount of coffee in the cup. Any questions there with that? Let's see, what was the points? 1 point for setting up the sum correctly, 1 point for this, and 1 point for your explanation. And then part D, what did part D ask? So the amount of coffee in the cup in ounces is modeled by this function. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So really all we're looking for here is b prime of 5. We're going to need to figure out what b prime of t is, since this isn't a calculator one. So if our function was 16 minus 16e to the negative 0.4 t, first off, that should be 16 will go away. Negative 16 is the constant out in front, e to the negative 0.4 t. That's just e to the negative 0.4 t times negative -0.4. And so negative 0.4 times negative 16 ought to be a positive 6.4. So we got 6.4 e to the negative 0.4 t. And we'll evaluate this at 5. 5 times 6.4 e to the negative 2. Or if you want to write it 6.4 over e squared, that's fine also. Either way. And did it ask for units on this one? It did not, so you don't need to put it, but this, I think they did on the scoring guide, if I remember correctly, ounces per minute. But it didn't ask for units, so you don't need to necessarily. And then this was worth 2 points, 1 if you correctly found the derivative, and 1 for getting the number. Any questions or issues there with that one? Everyone's good? All right. This one should be very, very similar to the last one. You'll note that this is, these show up pretty often. I would say every other year there's one of these type on the AP test. Should be easy points, hopefully. So we got temperature of water in a tub. This time they state that it is strictly increasing. So that's an important thing to note. And it's twice differentiable, et cetera, et cetera. The initial temperature is 55. And it's heated for 30 minutes. And it tells us values for the first 20. We'll have to deal with, it looks like 20 to 25 down here. So for part A, approximating W prime of 12. Just like the last one, we'll just take the smallest interval surrounding it. So we'll do 67.9 minus 61.8 over 15 minus 9. And this is a calculator, so you can use your calculator for that if you want. I guess that's, what is that? It's like 6.1 over 6. So let's see, scoring guide says that's 1.017. And doesn't specify units this time, does it? Oh yeah, it does. Using correct units, interpret what the meaning of this is. So this is the derivative of W, so this should be the rate of change of the temperature of the water. Since it's a positive number, it tells us it's increasing. So we'll say that the water temp is increasing at 1.017 degrees Fahrenheit per minute at our value of 12. And that was worth 2 points, 1 for the value and 1 for this one, for the explanation. Good? All right. Part B, a little bit different. We're going to evaluate the integral from 0 to 20 of W prime, and then talk about what that means. So integral from 0 to 20 of W prime, just using the second part of the fundamental theorem of calculus, should be the integral of W prime, which is W evaluated at the upper limit minus W evaluated at the lower limit. And just looking back at the chart, that should be 71 minus 55, which is 16. And in the context of the problem, this is an integral of the rate of change of the W, so that's the actual amount that the water temperature changed. So the water temperature, we'll say, increased by 16 degrees Fahrenheit on zero to 20. Everybody good there with part B? which is also 2 points, one for the value and one for your explanation. Any questions there? All right. Part C, they tell us that this is the average temperature of the water in the tub. They want us to use a left Riemann sum of 4 subintervals to approximate the value of 1/20th of this. So we're going to approximate the average water temperature from 0 to 20. So that will be 1/20th. And then using a left Riemann sum, first subinterval is 4 units long, so 4 times the 55. And then we've got 5 times 57.1. We've got 9 times 61, not 9, sorry, we got 6 times 61.8. And we've got 5 times 67.9. And you got a calculator for this one, so your calculator will tell you that that value comes out to be, looks like 60.79. And then it asks you if this is an under or an over approximation of the actual average temperature. And so because this function is increasing, so W is increasing, if we have an increasing function, left approximations will always underestimate the value. Everybody good there? That one was worth 3 points, 1 for setting it up correctly, 1 for the correct value, and 1 for underestimate with your reasoning why. Any issues there? All right, part D. So we got from 2025, W models the water temperature as a first derivative that's given by this. And we want to know what is the temperature of the water at T equals 25. So to figure out the temperature based on a rate of change of the temperature, we need to integrate that. We want to find W of 25. So we're going to have to integrate to find the amount that it changed between 20 and 25. And we'll have to add in our initial amount at 20. So we will do, what was the amount at 20? 71. So it will be 71 plus the integral from 20 to 25 of W prime of T dt. And that will come out to be 73.043. And 1 point for the integral, 1 point for the answer. Any questions there on D? How are we feeling about the miscellaneous ones?
Pretty good.
Yeah, good. So I think those are the only 3 I asked you guys to do. Is that correct? So for this one, we're given the graph of f prime. We're told that it's twice differentiable, first off. And we're talking about the closed interval from 0 to 8. They give us all these different areas of the different little sections between the x-axis and the curve. And we also know that f of 8 is equal to 4. So part A should be pretty straightforward. Part A is just asking for any values on 0 to 8, the open interval 0 to 8, so we don't have to worry about endpoints. Part F has a minimum. Well, F can only have a minimum if F prime is going from negative to positive, which tells us our function goes from decreasing to increasing, which would give us a minimum. So the only place on here where we have a critical value where it goes from negative to positive is right here. And so x equals 6, critical value, F prime goes negative to positive. And this critical value, we're going from positive to negative, so that's a local max. This critical value, we're going from positive to positive, and it is neither a max or a min. Everybody good there with part A? Part A is just worth 1 point. Okay. Okay, so part B, we're looking for the absolute minimum value of f on the closed interval from 0 to 8. So the only places where we could be at an absolute minimum are at the endpoints, so 0 and 8, or any place where we have a local minimum, which is 6. So we got to test 0, we got to test 6, and we got to test 8. And so in order to figure out, let's say, the value at, well, we know f of 8, that's easy enough. F of 8, they told us was 4, I believe. Correct me if I'm wrong on that. I'm pretty sure that's correct. F of 6 ought to just be the value at f of 8 plus our integral from 8 to 6 of f prime of x. And so in order to figure that out, we're going to want to know the integral from 6 to 8. Let's see, what did you say, Adrian? Why do I need to check f of 8 is in the local maximum? Yeah, it is. It does appear to be there. So you're right. We don't necessarily need to. We definitely need to check f of 0. I just was throwing on the endpoints because, you know, that's possibility for absolute minimum or maxima. I didn't really think about. I wasn't paying attention to whether it was a max or a min at those specific endpoints. But we do need to check f of 0 for sure. So when I made the integral, I put 8 on the bottom, and then my 6 or my x value on the top, because we are given the initial condition that f of 8 is 4. So the our starting point for every integral that we write has to be at 8, because we use that as our initial condition. And so your starting point is always your lower limit. Now the lower limit has to be on the top. I mean, sorry, the lower limit has to be that starting point always. You can't go onto the top. Yeah. All right. So what were we doing? Oh, we're looking for this. And so this integral, well, we know f of 8 is 4. This becomes minus the integral from 6 to 8 of f prime of x dx. And so the integral from 6 to 8 is 7. So this becomes 4 minus 7, or negative 3. So clearly that's less than it was at 4, which makes sense since it was a local minimum. But then we also need to find f of 0, which ought to be f of 8 plus the integral from 8 to 0 of f prime of x, which will be 4 minus the integral from 0 to 8 of f prime of x dx. We'll flip the limits and change the sign. So we got 4 minus, and then our integral from 0 to 8 is 2 plus 6 is 8, minus the 3 is 5, plus the 7 is 12. So we got 4 minus 12, or negative 8. And so our absolute minimum occurs at 0, and it is negative 8. Good or no? Any questions on that? That part was worth 3 points. 1 point, here you go again. 1 point if you considered f of 0 and f of 6. They didn't care if you considered f of 8, even though I threw it up there as a max. And then 1 point for your answer, and 1 point for all of the work that shows your justification for it. Everybody good there with part B? Okay, part C, we want to know when is f both concave down and increasing. So f is concave down if f double prime is less than 0, and it's increasing if f prime is greater than 0. If f double prime is negative, that tells us that f prime must be decreasing. So we are looking for places where f prime is both decreasing and positive. So that looks like that would be from 0 to 1, decreasing and positive. And it's increasing and positive, then decreasing and positive from 3 to, and then we're negative, and then we're increasing positive. It's like just 0 to 1 and 3 to 4. And they gave you 2 points for that one. 1 for the answer itself, 1 for the explanation, which is this. Any questions there on part C? All right, part D says the function g, so completely brand new thing that I haven't mentioned before, is f of x cubed. And we know that f of 3 is negative 5/2. So we want to find the slope of the line tangent to the graph of g at x equals 3. So we need to figure out 2 things. 1, what is g of 3? And 2, what is g prime of 3 to find the point, and to write the equation of the tangent. Oh, we just need to find the slope of the tangent line. Sorry, we don't need to find g of 3. So we just need to find g prime of 3. So first we'll find g prime of x. So g prime of x should just be the derivative of this, which should be 3 times f of x squared, and then times the derivative of f of x. So 3 f of x squared times f prime of x should be g prime of x. If we're looking for g prime of 3, it should be 3 times f of 3 squared times f prime of 3. And if we look in here, let's see, we'll have to find, they gave us f of 3 as negative 5/2 already. So we've got 3 times negative 5/2 squared, and then our value of f prime of 3, right there is 4. So times 4. And let's see, what does that come out to be? It looks like that comes out to be a positive 75. 25 times 3, and then the 4 is canceled. And let's see, if they gave you 2 points if you correctly found g prime, and 1 point if you correctly got 75 as your final answer. Any questions or issues on that one? Any questions on that? Everyone good? All right.